Hello everyone. I'm Andy from ThinkMo. I'm teaching CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is: will there be Layer 3 loop in PPP? How exactly does it come about? How can we avoid it? First, PPP. In the last issue, we mentioned that PPP is what we are talking about. The link type is called point-to-point protocol. We can review that. PPP is called point-to-point protocol. It is a point-to-point link layer protocol. And we covered that in the last video. Those of you who are interested can go and have a look. PPP, it has some corresponding advantages. Through the LCP protocol, this parameter is used to negotiate parameters of the link layer. The NCP is used to negotiate IP addresses. We talked about that in the last video. IP addresses of both ends of a PPP link, not on the same network segment. It's also possible to communicate. It also supports authentication. This is something that Ethernet cannot do. Now let's get down to business. The second aspect: what is a loop? On PPP link, it creates a loop. The loop is simple, and I send it to you. You send it to me, forming a circle. That's the idea of a loop. It's definitely not acceptable for a loop. And then there's the third question: how do PPP loops come about? There is only one line between two devices. How can you create a loop? Now we have an experimental environment. A 21A22, these two devices. Then configure the IP address of 1.1.1.2 for AR2. The IP address of AR1 is 1.1.1.1. Now AR1 and AR2 are on the same network segment. The mask is 24 bits. Those of you who have studied IP addresses know that the mask is 24 bits. That means 254 IP addresses are available. There are 256 of them. It involves the broadcast address, the concept of network address. Now the IP address is configured like this. Let's look at the AR2 device. IP address of the interface. This is what I've configured. AR1, also look at the interface IP address. It's also configured. 1.1.1.1 is. AR2 is 1. 1.1.2. It's the same as the topology. So we're going to use the AR1 device. Ping AR2 1.1.1.2. They are interoperable. We talked about that in the last project. Locally, it generates a 32-bit peer host route. 1.1.1.2 is. At the same time, it also generates 1.1.1.0. 24-bit. Same thing on the AR2. 1.1.1.1 will also be generated. 32. Which means that there is no problem with 32 we mentioned, because it's a host route. It represents a piece of equipment. That's for PI over 24 bits. It contains nothing but our present. For 1.1.1.1 and 1.1.1.2. Other than IP address. It may also contain 1.3 or 1.4. All the way to the 24-bit mask. The available range of IP addresses in it: 1.1.1.1-1.1.1.254. So what happens when you do that? Let's say we test it now. Tracert is path tracing. We can track this line. We can trace an example that doesn't exist. For example, trace 1.1.1.3. In this topology, there is no 1.1.1.3 at the moment. So let's test that out. We can see this phenomenon. It went through 1, 2, and then 1.1. And it goes back and forth. This leads to the loop we're talking about. Or you could call it layer 3 loop. Why is it called layer 3 loop? Because it's actually the same thing as last time. A route is related. Because there's going to be a routing table locally. This is what we call the roadmap. If it's just pi over 32, that's fine. But pi over 24 is a problem. In other words, it doesn't matter if I'm testing 1.1.1.3. Again, 1.1.1.4 or 1.1.1.254. You can send the data out. The data is sent to the peer AR2. AR2 does not have this IP address. So it's going to match up to pi over 24. This has 1.3 in it. So this is the data. In the process of sending it, it was sent back. But AR1 doesn't have that IP address either. At this point, AR1 will go to AR2. This gives rise to the concept of, in this case, the culprit is this 24-bit route. At this point, the solution is simple. This 24-bit mask. It can be configured as 30-bit. I'm going to give you a little preview of that. There are only 2 IP addresses available with 30-bit. 1.1.1.1 and 1.1.1.2. So let's test it out. Enter this interface. Change it to 1.1.1.1. And then we have pi over 30. Let's see if we have it configured. Interface S200. Same thing with the second one. 1.1.1.230. 30 contains only 2 IP addresses. Now let's look at the roadmap. It will only generate one host route. Pi over 32 and pi over 30. Let's say we come back. Test to 1.1.1.2. It doesn't create layer 3 loop. So why wouldn't it? Because there's only 2 addresses in there. AR1 sends the data to AR2. There is no other IP address. I don't send it back. And then it's over. Just send it once and it's over. That is, configure a 30-bit mask. I can solve this problem. And at the same time, it's also save IP addresses. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.